the key with it is understanding the psychology behind waiting in line. I know from a grocery store perspective, they will look at you in terms of trying to get you through if you have fewer purchases. The 10 items or less queue and the self-service queues at the grocery store have allowed them to process more and more of the customers who are coming in for quick pickup. Airlines, car rental agencies, all the travel components that I use frequently, offer frequent flyer services to allow you to get through special lines. And it's not just the airlines anymore, but it's actually the TSA. You'll see things like global entry and TSA pre and other areas to help just even at the security line perspective and not just to get your boarding passes. Additionally, you'll even see things around phone retailers. The how do you go about routing phone calls? And then you get into the bad parts of waiting. If you need a critical service, when you call 911, you really need to get someone there immediately, and that's not going to be a subject related to cost. So we're going to be looking at a couple examples, and I'll post onto Moodle some of the statistics and point you in the direction in the textbook to look at some of the models. But the two things that I will be talking about early on are first around the single server model, which would be that one single person in line to help you, and the other is different variations based off of service time, based off of queuing. So the examples that you'll see in the book are going to first focus on a basic single server model with the corresponding probabilities, as well as then service improvement. At what point is waiting in line too long? If I'm waiting in line at the dry cleaners, is waiting 8 minutes acceptable? What does it cost to then hire the additional cashier? And how does that increase from a cost perspective? And how much does that added cashier impact the bottom line of the organization? Can you get done more with less? I'll also provide some spreadsheets to allow you to walk through these items. The key is understanding service times and the queue length, and also understanding the population of who is going through the lines. For example, if I'm going through a car wash, typically from a car wash, you're going to see a single server line. I'm going through and I'm pushing into the queue if I'm going to a standard self-serve car wash. However, if you go to the higher end car washes, you'll see a multi-queue, multi-serve because of the additional services that are being offered, and then the population around those that are being served. If I'm looking at the overall characteristics for waiting in line, I need to understand the arrival characteristics, the wait line characteristics, the service characteristics, and the performance, as well as the costs that are involved. If we're looking at the different types of areas, at least the ones that stand out to me, supermarkets, paying for tolls on your way home after college, looking at getting in line for the ATM machine, going to the doctor's office. All of these things include the queue as well as the process and the different areas where it takes time and money to expand. If I'm going to look at changing a wait line system, I need to understand the inputs, the design, as well as the outputs. I need to understand the size of the population. I need to understand patterns. One of the things I hate at the airport is the restrooms after I land, because for some reason it seems like BWI lands all their flights at exactly the same time. And you get queued up when you're on that plane waiting to land because there isn't a good system in place, or at least it seems, in terms of managing those arrivals. So you'll see the same thing then in the food court at lunchtime. What are you dealing with in terms of how to expand or contract based off of high volume times? And then the behavior that we'll get in the queues. How many of you will go with a friend to wait in line, and each of you will get in 2 different lines to see which one goes quicker? So if we're using that car wash example again, let's think about the different parts of it. You've got your population of dirty cars and cars that need a wash. You've got the queue of the waiting line going into the car wash and then the exit of the system. When I'm arriving, you're looking at the number of cars you're going to be getting in line. And then when you're waiting, you're looking at how many cars can actually be serviced at the same time and the characteristics of that said service. If I'm going to the car wash and I want to get the hot wax and not just the standard wash, what does that impact? How does that impact my length of time in the queue? Is there a limited or unlimited length? Typically, from a queue perspective, you get a first in, first out approach in terms of the queue. But you also have to understand how the queue works in terms of preferential treatment. If there are 2 lines for a first-class passenger and a standard passenger for an airline, typically the airline is going to help the first-class passenger first. When looking at designing, as mentioned, you need to look at the channels as well as the time. Is the goal to get to a constant service time? That we want each customer to be through the car wash in X number of minutes, or each passenger to get checked in X number of minutes. And then from that, looking at the different queue. I'm going into a doctor's office. I have 3 people that are waiting for an appointment and 1 departure. I'm going through a McDonald's. I have 3 in the queue. I go to that first window and I pay. Then I drive up second. I go to that second window and I get my food. It allows the split. And that's a good way to look at single channel, single phase versus single channel, multiple phase. The best example for single channel, multiple phase is fast food. When you have 2 areas for service as part of the transaction. Now, if you are looking at it from a queue, for example, at Barnes & Noble. I'm not sure how many of you shop at Barnes & Noble, but if you go into Barnes & Noble, they have a single long queue, but then it opens up to multiple cashiers. That will be a good example of a multi-channel, single-phase system. If you go to Target, you'll see not only multiple cashiers, but multiple levels of registers where you can move in and move out at different components. If I'm going to look at the performance of the queue, I need to understand the length. I need to understand the average amount of time a customer spends in the system. I need to understand the number of customers or systems, and then the probability that the service will be idle, the utilization for the system, and the probability of a specific number of customers. You need to map for size and capacity. BWI needs to know exactly how many kiosks to have available for that Monday morning rush of business travelers, as well as that Saturday morning rush of people heading out on vacation. This allows for understanding of the costs involved, especially with expansion. If I needed to add more customer service reps at the Southwest ticket counter or more kiosks, how does that map from a service level to an optimum service level to an understanding of cost? As I mentioned, we looked at that single channel approach. I'm waiting in that 1 line. I'm going through, waiting in line, and being helped. First in, first out. It doesn't matter about preceding arrivals. All it does is basically allow you to step through. Now, with that, you're going to see the service time vary on the type of person that is supporting. And the service rate is faster than the arrival rate. In the next lectures, we'll talk about some other different queuing approaches that will help you look at what it really means to wait in line.